So we were asked to find um, the area or when it's revolved about the y-axis. So what we're gonna do right now is the following. First of all, we're gonna draw the picture. So it's gonna be somewhere here. Yes. And here. Yeah, that's good. All right. So what does the function e to the power negative x looks like? Well, we know e to the power x is this way. Since there's a negative sign over here, it's going to be this way. So we're going to just go ahead and just draw. See this little tiny area over here? That's the area that if we revolved about the y-axis, we'll get a function or a volume of a shape that we should figure out its volume. And so ln of 2 is about 0.693. I know that from chemistry. So it's less than 1. So if we say 1 is here, then it should be somewhere here, 0.69. That's where we want it. And so if we want to found the area as it revolves, this small white space should be reflected over here. And we want the area of that, so we want the volume of that. So zooming in, go draw another picture, a rough draft picture over here. That's gonna be this. That's gonna be over here. And so we see this if we zoom in. And that's ln of 2. If you recall, the formula for the shells method is volume equals the integral of 2 pi r h. Alright, so if we draw a shell over here, we notice that the radius, which is the one I just drew, this small space over here, is just x. As we go down, the radius gets bigger. And so we know x is the radius. Now the height function. The height function would be the function e to the power negative x. Why? Because at whatever x value we have, if we plug it into this, we're gonna find out y. And y is here is the actual height. And so this would be e to the power negative x. So the uh, the actual equation would be volume equals to 2 pi the integral of x e to the power negative x. And so evaluate from 0 to ln of 2. If so, how do we integrate this? We use the integration by parts equation, and that's the integral of u dv is equal to uv minus the integral of v du. And so we insert our players u in dv, v du. Alright, so we figure out who's u and who's dv over here. If we plug in x to u, we'll have 1, which is perfect. if we plug in x over here, we'll get x squared over 2, and that's hard to deal with. And so we go ahead and insert x over here and e to the power negative x over here. The derivative of x is simply 1 dx. And the integral of e to the power negative x is e to the power negative x divided by negative 1, which is simply negative e to the power negative x. We go ahead and plug in the u v's, and so u is x, v is negative e to the power negative x, and we have minus the integral v, so that's going to be a plus e to the power negative x du dx. And so evaluated, the whole thing is evaluated at 0 to ln of 2. So we go ahead and put 0 to ln of 2 over here, and negative x e to the power negative x evaluated point. Now I'm separating it into two parts. Plus, well, what is the integral of e to the power negative x? That's simply negative e to the power negative x. And so this is cancelled. Evaluated at point 2, ln of 2, and 0. Now, I'm running out of space, but here we go. So that's ln of 2 e to the power negative ln of 2 minus, this would be 0, because negative 0 times whatever is 0, so that's 0. However, we have that as, remember we had a positive sign over here, which is a plus sign, but it got canceled out by the negative, so we put the negative over here, and it's going to be negative e to the power negative ln of 2 minus e to the power minus, so that's a plus, e to the power negative 0. That is simply 1. This we should figure out. So let's go over here. So what would that be? Let me get the calculator. Negative e to the power negative ln of 2 is negative 0.5. So this is negative 0.5. So that's 0.5. So this whole bracket is 0.5. So we just say minus 0.5. Now let's evaluate that. So that's negative ln of 2 e to the power of negative ln of 2. That's negative 0.35 approximately. So that would give us negative 0.35 plus 0.5. So sorry, that's going to be negative 0.5. That's going to be negative 0.85. But remember, we had 2 pi over here. And so we're left with 1.7 pi. That's our answer.